In this video, we're going to work through a couple of problems in our Study Guide A Significant Figures worksheet. So if you turn to the second to the last page, it's the last page, but the front of the last page. Here, we're looking at, they're asking us in this first column, the number of sig figs. And in the second column, the precision. And the reason the precision is important is if we were taking this number and adding it to another number, then we would need to use the least precise number involved in that situation. So these two zeros are leading zeros. Leading zeros never count, so the 5 and the 2 counts, and it's 2 sig figs. And the precision is to the tenths, hundredths, thousandths place. So you could write this one of two ways. You can write it as plus or minus 0.001, that's to the thousandths place, or you can write it to the thousandths place. It's precise to the thousandths place. This zero is a trailing zero, but it's a trailing zero to the right of a decimal. So the 1 counts, the 5, the 1, the 1, the 5, the 3, and the 0 counts. So there are 5 significant figures, and once again, it's precise to the thousandths place. Now we have to be careful with this one. In the rules that we read, if you're counting objects, if you're counting object, there is no error in your counting. They're complete full objects. There are 14 iPods. There's no error in that. So the number of significant figures we say is infinite. It's got an infinite number of significant figures and an infinite precision. Same thing when you're dealing with conversions. There are 1,000 milliliters in a liter. This is a number of items, and this is a conversion. When you're dealing with conversion factors, there is an infinite number of significant figures. We don't pay attention to significant figures when looking at the conversion factors. Same thing here. 75 beakers, you're counting. So infinite number of significant figures. 24 hours a day is a conversion factor. Infinite number of significant figures. 144 motorcycles. There's not, well, I think there's 144 and a half. No, you're counting the number of motorcycles, so there's no error in your measurement. How about 1,001 tons? This, zeros are middle zeros. The ones count, so there are 4 significant figures, and it's a plus or minus to the ones place. You can write it out as the ones place, or you can put plus or minus to the 1. Notice this. All of these leading zeros do not count, but trailing zeros to the right of the decimal, these are trailing zeros to the right of the decimal count, so it's 3, and then it's plus or minus 0.1, 2, 3, 4, 5, and then the 6th one. 1, 2, 3, 4, 5, and the 6th one. Okay. Now, I hate that they use this, but I guess there are times that this shows up. When there is a decimal, this is a trailing zero, but because they put a decimal right here, they're telling you that it really counts. They should have written it like this: 3.40 e to the 2, then you know that 0 counts for sure, or they could have put 3.4 e to the 2 if it didn't count. Another way to write that is a decimal there. I don't like it. It shows up sometimes. So there would be 3 sig figs plus or minus to the ones place because that 0 counts. All right, what if we are rounding? What if we're supposed to take this number around to 2 sig figs? It would just be 76. What if we were taking this to this place right here, the hundredths place? We would have to put 680.00. If we're rounding this to the nearest sig fig, there. Here, let's say 2 sig figs, so it'd be 5.6 e to the 2nd, or 10 to the second. Okay, so I hope this helps with looking at sig figs. The other for this one right here, we move the decimal place 3 places to the left, so it'd be 0.001020. This 1.020 e to the negative third is the same as this number. So if we're going out to the 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, it does not change. It just looks exactly the same. Then on the very last page, we have some examples of adding, subtracting, multiplying, and dividing. So let's look at this first example here. We have 0.02123 plus 1.12 plus 0.00123. When I take those three numbers and put them in on my calculator, when I add it up on my calculator, this is what I get. 1.14246. But here's the rule. When adding and subtracting, we look at the precision of each of the numbers, then we choose the one that was the least precise. So this is the tenths, hundredths, thousandths, 10,000ths, 100,000ths it's precise to. This is precise to the tenths, hundredths, and this is also precise to the 100,000ths. The least precision is to the hundredths place. So my answer can only be precise to the hundredths place. The next number is 5 or less, so my answer would be 1.14. Now, let's take a look at letter B. Letter B, we get 3.3, subtract 2.43, and then plus 230. So when I take those three values, on my calculator it shows 230.87. This is precise to the tenths. This is precise to the hundredths. Notice this 0 does not count. This is only precise to the tens place. So the worst precision, the least precise, is to the tens place, so we can only go to the tens place. So the final answer would be 230, but really I would want it as 2.3 e to the second power, indicating that it was precise to the hundredths place. You move the decimal 2 places over to get 230. But this is a little bit ambiguous. There's times where people are like, well, does a 0 count or does it not? Someone say, oh, well, if you put a decimal, then it counts, but if you don't, it doesn't. But it's just more clear to write it in scientific notation. I hope this helps with identifying addition and subtraction and using the least precise number, as well as identifying the number of sig figs and the precision.